Welcome to myprojectbazaar.com. Our product title Analysis and Optimization of Product Accumulation Section 4 Efficient Implementation of FAR Filters. Now we are going to discuss about our product abstract. In our process, we have mainly focused on a precise analysis and optimization of critical path for transports direct from FAR filters. And then the delay increment introduced by the structural address is estimated by the comparing the delay of tab and the corresponding delay of the coefficient multiplications only. Based on the novel implementation of the product accumulation sections of FAR filters, the existing delays into the structural address, and then we have structural address can be integrated with the MCM multiple corresponding process, and the block together further reduce the critical path by using the delay caused by the structural address can be either completely eliminated, and then the experimental statistical path of significant and reduce the cost of process. In here we are using the fundamental building block for the digital signal processing process. And then the FAR filters important of the high speed and low power realization of DSP process. The FAR filters transport direct form for the structural, and the direct structural for the pipelined structural storage critical path delay. Most of the process designs and implementation of the FAR filters so far focus on the optimization of the MCM block. Now we have observed that product accumulation sections often contributes of the major part of the critical path, such that the optimizations MCM blocks in impact of the overall speeding of the FAR filters. And then we have referred the benchmark FAR filters and the critical path delay of corresponding MCM blocks. In our process, we have FAR filters the such higher than of their corresponding MCM blocks. They have the most of structural address of the product accumulation process. And then we have using the FAR filter process algorithm. Basically we have implemented the K algorithm and the Kodak algorithm process, the efficient implement of the process, and then we high speed and low complexity of the process of FAR filters. Now we are going to discuss about our product flow diagram. In our process, we have giving the clock and the giving the signal input data bits. We have designed the 16 input data for the filtering process, and then we have creating the coefficient generator architecture. In the first we select the coefficient bit using the mux logic functions. The functions is consist of first and second coding pause logic level. This pause logic is applied to different tab band coefficient signals, and to add the signal coefficients level. The coefficient generator architecture is to process the phase optimization control process. And then we are going to implement that first coding pause functions and second coding pause functions, and then PBG unit shift architecture process, and then shift adder architectures. In the process with the PBG circuits used to modify fixed point LMC adaptive algorithm process to reduce the multiple apparatus is using the shift adder tree method. This method is used to optimize the multiple gate account, so reduce the power consumption level. To perform the entire operation for getting the final product, the conventional architecture to for shift and odd multipliers require the many switch activities. And then process we are going to the channel selections logic blocks. The channel selections logic functions is differing from every tab input selection level. The channel selection process is reduced to the error bits to original signal level. Finally we collect the 3 tab mux selection signal process, apply the coefficient selections control for the mux selection source, and then mux selections logic for the data accumulation process. The process the reconfigurable FAR filters is based on the transposed direct form architectures. The finally accumulations blocks has been the chain and 6 adder and 6 register as a level of the 7 sub filters. And this we go into the finally data accumulation process completed. We are going to the synthesis and the simulation result. Finally we design the 8-bit and channel based FF filters, the digital architectures. These architectures are used to reduce the noise level for the given signal received signals. Then simulate the final output binary results to calculate the circuit complexity, power and speed level. Our process architecture FF architectures code was developed by the PHP language. Now we will discuss about our process running procedure. We have designed our process FF filter designed in the Xilinx 14.2 version tool, and then I have running the simulate the power process simulation process. After we click that we simulate behavioral model process, we get output for the simulated in the ISIM process. The process simulate behavioral model completely successfully finished. Automatically open the ISIM simulator process. In the process we have give the input for the clock and DIN input process, and then get output for the RRC output process in the FF filters. So we have given the input process for that clock. The clock process is using the leading edge values zeros and the trailing edge values ones, and 1000 nanosecond for the periods. So open. Process apply and OK, and give the input value for the constant values. And then give every values we have designed to simplify the process. After the simplify for the giving input for the radix, we have designed the ancient value for that. We have giving the value for the after completing the process, we get the input for each and every line for the constant value, force constant and sign process decimal values. We can give out this binary codes for like this process. After giving the all input values, we can just running the process. We get the output for the RRC output for this process. What are the we giving input for DIN, we get the output for here this process. So after complete this process FF filters, now we are going to discuss implementation result and utilization result. So here implementation, we get the process here implementations, we get the synthesis report and the implementation result. View RT schematic diagram. This process we main, add the process main, check the create the schematic diagram process. We have designed the IC's main process, here the process for the inbuilt of the process. This we get the schematic diagram for the we designed the IFF filter process 16-bit for process. It will be open the schematic diagram for the FF filter 16-bit process. We can using the process. This is also schematic diagram for this process. So this is IC design for the inbuilt of the process IC designs. We have create the view RT schematic diagram process, the technology schematic diagram process. After we go into the check for that simulation result for that process. Thank you viewing our product website.